All right, welcome back. Let's check out some calculation questions. So I have a worksheet that's in front of me. I'm not going to go through all the entire 4 pages of worksheets, but let's select some questions to do. This is here's an example of how to read the graph. So find the curve for potassium chlorate. How come my pen is not working here? Potassium chlorate, and we need to look at this scenario at 30 degrees. So potassium chlorate is down here. At 30 degrees, approximately 10 grams of potassium chlorate will dissolve in 100 grams of water. If the temperature were to raise to 80 degrees, right around here, you would have about, let's see, about 40 grams of solute. So the answer here will be your 40 grams. And it's really important to have your units. So 40 grams of solute will dissolve in, of potassium chloride will dissolve in 80 degrees. So let's look at these questions. What mass of solute will dissolve in 100 milliliters of water at the following temperatures? So the first one is potassium nitrate. We're looking at 70 degrees of this curve. So follow my 70 degrees and you will get to this point. And now look at this number, that's 130. So this is 130 grams of potassium nitrate that you can dissolve in 100 mLs of water. Next one is sodium chloride. So this is sodium chloride at 100 degrees is right here. So it's right on the line. So it's at 40 grams of sodium chloride. So that's 40 grams of solute. And lastly, ammonia chloride. So this is your curve of ammonia chloride at 90 degrees. It's right here. You can see that this goes all the way to 70 degrees. So it's not 70 degrees, 70 grams. So that's your 70 grams of solute. And then the question here at the last one is which of the above three substances is the most soluble in water at 15 degrees? So which one can you dissolve the most things? So this is the 15 degrees. So you want to look at the one that has the highest point, right? Because as higher up you go, the more solute you can dissolve. So potassium nitrate is right here at 15 degrees. Sodium chloride is right here, and the last one is ammonia chloride, which is down here. So the answer here is NaCl. So that's your answer. That's how you read a solubility curve. So let's look at some other questions here. Is that some challenging calculation questions. You're looking at what mass of lithium sulfate? Oh, these ones are not on the solubility curve. Let's not do these ones. When 30 grams of potassium nitrate is dissolved in 100 grams of water, the solution can be described as, is this going to be unsaturated, saturated, or supersaturated? So let's look at potassium chlorate at 20 degrees. So potassium nitrate, sorry, at 20 degrees. And this is about a little bit over 30 grams. So let's say that that's at 33 grams. But right now I have 30 grams. So the saturation point is at about 33 grams. We have 30 grams. So we can say that this is still unsaturated. So this is your unsaturated solution. Let's choose another example. Let's look at number 3. What mass of potassium chlorate could be dissolved in 100 mLs of water at 70 degrees? So simply I'm just going to look for potassium chlorate, which is this line right here. And I think it's at 70 degrees. So let's look at 70 degrees right here. And this is going to be, that's all the way over here. This is going to be about 33 or 34 grams of solute. So that's your answer, 33 grams of solute. Sometimes you're asked to find the mass of something that is not 100 grams of water. So let's say that if you were to find something that's at 300 grams of water, and you want to figure out what the solute amount is. How I would do this is that I would still look at, we have to have a temperature here, so let's look at 50 degrees of, let's say, potassium nitrate. So let's get some more information. So 50 degrees Celsius of potassium nitrate, and the question is asking you how much solute can you dissolve if you have 300 grams of water. So I would still use the times division bar because it sets up the ratio, but here is where you have to be very clear with your units. So grams of water is at the bottom, and now this is where it gets a little bit tricky because your grams of solute is still grams. So you're going to have a grams up at the top and grams at the bottom, but it's the grams of solute, which is your potassium nitrate. So be sure that you have your units correctly and don't just write grams. And then now you have to find the numbers that fill in here. So look at 50 degrees and then look at potassium nitrate. So at 50 degrees, you will dissolve 80 grams of solute. So remember, this is 80 grams of solute in 100 grams of water. And you can see that this is actually just a ratio, right? Like this is 300 grams, you have 100 grams. You're basically just multiplying this by 3. So this is going to be 300 times 80 divided by 3, or just cancel out these zeros. You're going to have 240 grams of potassium nitrate. So this one is relatively easier to see because you have 300 grams and it's like a ratio. But what if you were to ask about, let's say, 0.33 grams of water of potassium nitrate at 50 degrees? This is where it gets a little bit tricky, because how do you find the ratio of 0.33 grams with 100 grams? So that's why setting up this division, your unit analysis is very useful, because you want to get rid of grams of water, so you put grams of water at the bottom, and you try to figure out the grams of solute, so you're going to write grams of solute at the top. So then you're going to write the same numbers, but now it's just your setup. It's just that you're using this number. So that's the difference. And that's the advantage of using your unit analysis, because now it doesn't matter what you start off, what number you start off with. If you know that this unit is going to get canceled and this is the unit that you want, you will always get the right number as long as your setup in units is correct. And that's really the scope of all the solubility curve questions. Just reading the curve. This is one of the only sort of more challenging calculations, but all the other ones are just really reading the curve. Make sure you're reading the temperature correctly and the grams of solute correctly. So hopefully this video has helped you. Thanks for watching.